this video, I'm going to be talking about how we can use the form y equals mx plus c to work with lines and equations. So in my last video, I explained what we mean by the form y equals mx plus c, and I explained that if we happen to have something in this form, then I automatically know that the gradient is that m, whatever that is, and the y-intercept is that c, whatever that is. So if I happen to have an equation in the correct form, I instantly know the gradient and the y-intercept of the line. So we can use this fact in two different ways. The first way we're going to be using it is to take an equation and draw the line nice and quickly, just using that information. So if I have the equation y equals negative 2x minus 1, then just by looking at this just by looking at this equation, I instantly know that this is my c, so the y-intercept is negative 1. I know that straight away, and I can mark that straight away on my graph. The y-intercept is negative 1. I also know that the gradient is negative 2, just by looking at y equals mx plus c, y equals negative 2x minus 1. The gradient has to be negative 2. Now, if you remember, the gradient of a line is the amount that y increases by as x increases by 1. So that tells me if I increased x by 1, which is what this line is doing here, I'm increasing x by 1, then I'm going to need to increase y by negative 2, which is a fancy way of saying decrease by 2. So you can see how I've gone from negative 1 down to negative 3. I've increased by negative 2. And so that coordinate must also be on my line. Straight away, because all we need to draw a line is 2 coordinates. So just from that bit of information, I can draw a line. So hopefully you can see this is a lot easier than drawing out a table and finding what minus 2x minus 1 is for every value of x we can think of. For this, I only need to use the information from y equals mx plus c to draw the whole line. So I would just put my ruler on those 2 coordinates and draw the rest of the line. Okay, let's now try with y equals 3x plus 0.5. Now I know just from looking at this equation that we've got our plus c here, so I know that the y-intercept of this line is 0.5. And so I can put that on straight away. I also know that the gradient is 3. So that means that as x increases by 1, y increases by 3. That means that this coordinate here also has to be on the line y equals 3x plus 0.5. If I put my ruler on those 2 coordinates, I can draw the line. One more example of this. So here I've got y equals negative 1/3 x. Now this is in the form y equals mx plus c, as I explained in my last video, but it just means that c is 0. So the y-intercept of this line is 0. I can plot that on straight away. I can also see, using y equals mx plus c, that the gradient of this line is negative 1/3. So as x increases by 1, y increases by negative 1/3, or decreases by 1/3. Now you might be a little bit worried that this isn't exact enough, because 1/3 we want to mark it on exactly. So you may instead want to plot this coordinate down here, which we can find quite quickly by doing x as 3. So then 1/3 times 3 is negative 1, which is what we've put here. But the way I did it originally would be fine. So you only need these 2 coordinates. This extra coordinate is optional, but it would make our answer a little bit more exact. It would make our drawing a little bit more accurate. Either way, I can put my ruler on whichever 2 coordinates I made, and I can draw the line. So this is the line y equals a negative 1/3 x. Okay, so that's one thing we can do with this form y equals mx plus c. We can take an equation and we can draw the line nice and quickly. And that's useful, that's powerful. But what we can actually do, which is even more powerful, which turns out to be even more useful, is we can go in the opposite direction. We can take a line that somebody's already drawn for us, and we can instantly find the equation of that line using y equals mx plus c. So here's our first example. This is a line. I don't know what the equation of the line is, but I can find out. Because I know what the y-intercept of this line is. I can see the y-intercept is where it goes through the y-axis. So the y-intercept of this line is 1. I can also, using a previous video, work out what the gradient of this line is. So to find the gradient of a line, I just need any two coordinates on the line, and I find the difference in y divided by the difference in x. So in this case, it's 1 divided by 1, which is just 1. Okay, so using those two bits of information, using how I find the y-intercept and how I find the gradient, I have found that the gradient is 1 and the y-intercept is 1, which means that if y equals mx plus c is my form, it's going to be y equals 1x plus 1. Now, just to remind you that by x we do just mean 1x, so there is a secret 1 here that I've chosen not to put on. Now that is a lot easier than any other way to find the equation of a line that we've seen so far. So from the line that was drawn, I was able to work out what equation must have been used to draw it, and it was y equals x plus 1. Let's have a look at another example. So we've got a line here. Again, I don't know what the equation is yet, but I can see that the y-intercept here is negative 1. So c is going to be negative 1. I can also work out the gradient. So if I look at this, any two coordinates, and look at the difference in y over the difference in x. So y here is, well, 2 or negative 2, whichever way you want to think about it. And the difference in x here is 1. I know this is going to be a negative gradient because it's going downhill. So my gradient is negative 2 over 1, which is negative 2. Of course, we could also think of that as we increase x by 1 and then we go down by negative 2. That's also fine. They're equivalent ways of thinking about the gradient. Either way, we get the answer negative 2. So using my y equals mx plus c, I know that it's going to be y equals negative 2x minus 1, because the gradient needs to be negative 2 and the y-intercept needs to be negative 1. Okay, next line. I can instantly see that the y-intercept of this line is negative 2, so I can write that down straight away. I can work out the gradient by drawing this triangle. So these are the two coordinates that I'm talking about. The change in x is 1, sorry, change in y is 1, and the change in x is 2. So the change in y over the change in x is 1 over 2. And I know it's going to be positive because it's going uphill. So we've got the gradient as a half, which means that y is a half x minus 2. I can instantly draw on my y-intercept. I can find the gradient using these two coordinates. The difference in y is 4. The difference in x is 3. So my gradient is going to be 4 over 3. And it's going to be positive because it's going uphill. So the gradient is 4/3. So my y equals mx plus c would be 4/3 x plus 0. But actually I'm just going to leave it as y equals 4/3 of x, because I don't need the plus 0 on the end. Okay, so the y-intercept is 1.5. I can find the gradient by considering these two coordinates here. change in y is 5, the change in x is 2, and it's a positive gradient because it's going uphill. So we've got 5 over 2 as our gradient. That means that y is 5 over 2x plus 1.5. Obviously, I could turn that into a decimal, or I could turn that into a fraction, but I've just decided to leave it as it is because it's fun. So what we can do with this is we can use the form y equals mx plus c to write an equation given the line and given that we can work out the y-intercept and the gradient of that line. Okay, so the key points in this video. If we have an equation that happens to be in the form y equals mx plus c, we can draw the line using the fact that c is the y-intercept and m is the gradient. Going in the other direction, if we have a line, we can find the equation of the line in the form y equals mx plus c by finding the gradient and the y-intercept. And if you struggle with either of those two things, it might be worth practicing those skills a little bit more, because we do need to be able to find the gradient and the y-intercept to use this fact.